And now we hop on to question number 9, which is based on probability. Right, I know this is our favorite section, right? All right, so they say to us, a company is investigating whether employees working from home are more likely to meet deadlines. 150 employees were monitored and the following was found. They say the probability that employees work from home and meet deadlines is 0.38, okay? And the probability that the office workers do not meet deadlines is 0.4. Right, so they've given us a contingency table there. And the first question says, determine the value of A, the number of employees that worked from home and met deadlines. So there's A over there, the probability that someone worked from home and met deadlines. And we know, in this case, they said to us the probability that someone worked from home and meets a deadline is 0.8. So meaning that the probability that someone works from home, that's A, divided by the total number of the population size, which is 150, right? This is going to be 0.38. Okay, right, so what would be our value for A? So that would be A is 150 times 0.38. Okay, and if we calculate that, 150 times 0.38, that gives us 57. So the number of people there, that's 57. So we know this is going to be 57. All right, and so that will enable us at least to find out what the other values are. And they say the probability, they say determine the values rather of B, C, and D. Right, let's deal with the other probabilities. So they said to us the probability that the office workers do not meet deadlines. So which means we are looking at this here. We're looking at D, right? They said that is 0.4. So again, the probability that we've got an office workers, so that's the number of people that do not meet the deadlines divided by the total sample size or population size, and this is equal to 0.4. So in that case, it means that D times 150 times 0.4. Okay, again, and that's 0.4. So that means that we've got 60 in total. All right. And now we would be able to calculate the numbers. So that's 60. Okay. So now, which means the value of B, remember A plus B should give me 80, right? So that means B would be 80 minus 57. All right, and then the value of C, this means C plus D should give us 70. So which means C plus 60 is equal to 70. So the number, oh sorry, I didn't give an answer there for B. So that would be 23, right? So that would be the number of people there. So this would be 23. And when we look at C, the number there is 10. Okay, right. So we've got the total number. We've found the value of B, C, and D. All right. Now, on the next question, they say refer to the contingency table above and justify whether the company should encourage employees to work from home or work from the office. All right, now let's have a look at the data. What does that tell us? It tells us it looks like we've got more people who work from home meeting deadlines. I wonder if this is true. Okay, So people who work from home are more likely to meet deadlines than people at the office. All right. And you can even see that people at the office, right? There's a small number of people that work from the office that meet deadlines. So I think people working from home are likely. Okay, so in this case, we can say the number of people working from home that are likely to meet deadlines is higher than people at the office. So as a result, I would definitely encourage people. Therefore, the company must encourage people to work from home. More people to work from home. All right. All right, and you can explain this in your own way, right? Just by looking at the data in your contingency table. I think it tells us more than what we want to know. All right, so let's go to the next question. They say, I don't know whether this is Peter or Peter, but I think it's Peter, has 5 cards which, with numbers, he randomly chooses the cards to make up a 5-digit number. All right, so definitely this is... so we are going to be looking at how to look at permutations and combinations. In this case, they say how many 5-digit numbers can be formed with these 5 digits. Now, for people that have seen me work these sort of questions out, you know that I always use that block method of mine, right? And it always works well. In my opinion, I find it to work much, much better. Right. So that means, right, we've got 5 digits. So how many digits can we choose from? All right. So in this case, for the first digit, I can choose from 5. If I've chosen 1, I can choose from 4. If I've chosen 1, I can choose from 3. If I've chosen another one, I can choose from 2. And of course, we'll only be left with 1 thereafter. All right, so which means how many different digits can be formed with these? I mean, how many 5-digit numbers? It means it will just simply be 5 times 4 times 3 times 2 times 1. And as you guys all know, this is simply 5 factorial. Okay, right, we can work out what that is in terms of the number. Okay, that's 120. So that's 120. All right, now they say to us, what is the probability that the 5-digit number will have 2 4s next to each other? Right, so what are we going to do? We're going to treat the 4s as just one, as just a bundle, right? So I want you to note, so in this case, we are grouping the 4s together. So we're going to take those 4s together, right? Right. But in this case, I want you guys to note, grouping the 4s together, we're taking them, as one, okay? But I'm still going to talk about the 4s themselves. Right. Let's do this. Let's assume we've got a green 4, right? We're going to treat them as different, and a RAID 4. Okay, right, so that you can understand this better. Right, we are grouping those together. So which means how many combinations can how many choices do I have for the first one? Well, I've got 4 because I can either take the 1 or the group of 4s or the 6 or the 9, right? So in that case, I've got 4 to choose from, okay? And then once I've chosen, I've got 3 to choose from, I've got 2 to choose from, and I've got 1, right? But remember that we can still swap around the 4s, right? So there's 2 ways in which we can place the 4. So you can say this is actually multiplied by how I place my 4s. So I am also going to say multiply by 2 factorial because there's 2 ways in which I can so multiply by 2 factorial, right? Or multiply by 2. So in that case, it means it's for 4 factorial multiplied by 2 factorial. Now, you can say to me, but would it matter? Would it matter which 4 I place first? Well, it doesn't, but if you think about it, it still is a card that you have. So the probability still exists, right? In the order in which you place those 4s, right? So they say to us, what is the probability that the 5-digit number will have 2 4s? So now, which means if we're taking the probability, we'll say that, well, that is 4 factorial multiplied by 2 factorial divided by 5 factorial. Okay, so that's 4 factorial times 2 factorial divided by 5 factorial. Okay, and that probability is 0.4. And why did we divide by 5 factorial? Because that's the total number of ways in which you could place those cards. So that is 0.4. That's our probability. Okay, right. And then finally, they say to us, what is the probability that the 5-digit number will be greater than 50,000 and an even number? Ooh, right. Now, what's the likelihood for us to have an even number? So in this case, it would be even if we take 4, the other 4, and 6, right? So let's suppose in this case, let's take the first permutation, right? Okay, I just want it to be nicer. Okay, so here's our 5-digit code. Right, now I want you guys to please listen to me carefully. So they said it should be greater than 50,000. Now, how can it be greater than 50,000? That's if I take either the 6 or the 9, right? Now, please, I want you to note 6 is already even, right? So in this case, let me take different combinations. Let's say if I use the 6, right? So supposing the first number that I use is 6. How many 6s do I have? There's only 1, right? Okay, this is if I use 6 as the first number. I'll take another one where I can use 9 as the first number. There's only 1 6, and so that is an even number, right? Now, how many even numbers am I left with if I have now used the 6? I've got 2 even numbers that I am now left with, okay, which are the 4s. So I can choose from those 2. Now note, right, I've chosen a number here, I've chosen a number there. Right, now how many numbers would I be left with? If I've already chosen 2, so in that case, I'm going to be left with 3 to choose from, 2 to choose from, 1 to choose from. All right, now this is all if I use the 9. Okay, so if I use the 9, I can be able to use, right, so note again, so if I use the 9, so I've got the 9 over here, so it's only 1 9, right? I want the number, if I used 9, I want you to note, if I used the 9, how many even numbers can I choose from? I can choose from 3, right? So in that case, it means I've got 3 over here. All right, now I've chosen from 2. So how many numbers do I have? I've got 3 to choose from because it can be any of the ones that are left. I've got 2 to choose from. I've got 1 to choose from. So those are the combinations that I can have. So they said probability. So I'm going to have, all right, that's going to be 1 times 3 times 2 times 1. Okay, so that's 1 times 3 factorial times 2 plus 1 times 3 factorial times 3, right? That's the total number. But remember, because we are looking for a probability, we are still going to divide this by the total number. And in this case, we said that was 5 factorial. Ladies and gents, I hope that you understood this. Okay, you know, when it comes to counting principles, sometimes, yeah, they can give us, show us flames a little bit, but I hope that you understood what I tried to explain there. And you're more than welcome to look at my explanations that I've given in my videos on counting principles. All right, I just want to give you the final answer. Multiply 3 factorial times 3, and this is divided by 5 factorial, and it is 0.25. All right, and that's how the cookie crumbles, and we will be looking at the next question in the next video. Stay tuned.